Do you actually need a high-end PXI controller? Or are you just paying for specs you'll never use? In this video, we're breaking down what PXI controller specs actually mean, and more importantly, when you actually need more of each. A PXI controller is essentially the computer inside your test system. It's responsible for running your software like LabVIEW or TestStand, communicating with your PXI modules, and processing and storing your data. So when you choose a PXI controller, you're really deciding how powerful you want your test system to be. Everything else, your modules, your timing, your measurements, depends on this. Let's start with CPU because this is the most misunderstood spec. The CPU controls how fast your system can execute test sequences, process measurement data, and run multiple threads or instruments at once. Now here's the key distinction. Data acquisition is not always CPU heavy. If your PXI system is mostly streaming data to disk, acting as a measurement front end, and running simple loops, then the CPU is not your bottleneck. But the moment you introduce real-time signal processing, FFTs or filtering, complex LabVIEW applications or multi-instrument coordination, CPU becomes critical. You'll especially notice CPU limitations when your UI starts lagging, your test sequences slow down, or your system struggles to keep up with data rates. Rule of thumb: if you're thinking this system will grow later, don't underspec your CPU. Next is RAM, and this is where a lot of systems quietly run into problems. RAM determines how much data your system can buffer, process, and hold in memory at one time. This matters more than people think. Here's when RAM becomes important: high-speed data logging, large waveform captures, running multiple PXI modules simultaneously, or using environments like LabVIEW and TestStand together. However, real-time doesn't need as much RAM. If you don't have enough RAM, you'll see slower performance, dropped data, or even crashes. But at the same time, not every system needs 16 or 32 gigabytes. For many applications, 4 to 8 gigabytes is perfectly fine. 8 to 16 gigabytes is a safe middle ground. 16 plus gigabytes is for high-performance or data-heavy systems. Key idea: RAM is about stability under load, not just speed. RAM also depends on your operating system. Windows 7 will work with 4 to 8 gigabytes, but anything newer will need at least 8 gigabytes. Storage is often overlooked, but directly affects how your system behaves. There are 3 main considerations. 1. Speed, SSD versus older drives. Most modern PXI controllers use SSDs, which are faster, more reliable, and better for continuous logging. 2. Capacity. Ask how much data are you collecting per test, and are you logging continuously? If you're recording high-speed data, storage fills up fast. 3. Removability. Some controllers offer removable drives, which is huge for secure environments, field deployments, and quick data transfer. Instead of pulling data over a network, you just swap the drive. This is the most overlooked spec: bandwidth. Bandwidth determines how fast data moves between your PXI modules and your controller. This matters a lot if you're using high-speed digitizers, RF modules, and multiple simultaneous acquisitions. Even if your modules are fast, your system is only as fast as the controller can handle. If bandwidth is too low, you'll see data throttling, latency, or incomplete transfers. This is especially important in multi-channel systems and high sample rate applications. PXI's advantage is that it uses PCIe architecture, which allows very high throughput, but your controller still needs to support it. So how do you choose? Think in terms of your application, not specs. A basic system with simple data acquisition, low-speed logging, and minimal processing needs a lower CPU, moderate RAM, and standard storage. A mid-level system with multiple modules, moderate data rates, and some processing would benefit from a balanced CPU, 8 to 16 gigabytes RAM, and a SSD. A high-performance system that utilizes high-speed digitizers, real-time analysis, and complex automation would be best with a high CPU, high RAM, and a high bandwidth. At Apex Waves, we help customers choose PXI controllers every day. And here's the truth. Most people don't need the highest-end controller. They just need the right one for their application. Choosing correctly saves money without sacrificing performance. If you're building or upgrading a PXI system and want help choosing the right controller, feel free to reach out. We're always happy to help. This concludes today's video. Thanks for watching. If you're looking for legacy NI parts, calibration services, or more technical resources, head on over to apexwaves.com to get what you need fast. We have thousands of NI parts in stock and ready to ship, including legacy and obsolete modules you won't find anywhere else. And if you found this helpful, don't forget to like this video and subscribe to our channel for more product highlights, how-tos, and industry insights.